Good day, everyone. Today, we will be discussing another important topic in assessment and learning. This PowerPoint presentation is with courtesy of the ASE Math 2A. This is entitled Item Analysis and Evaluation. Let's proceed. We will be discussing the concepts of item analysis, the index discrimination, and item difficulty. With this discussion, we're expected to learn how to differentiate the concept of index of discrimination and item difficulty, analyze the effectiveness, difficult discriminating power of each item of the test, and demonstrate the skills in computing the item analysis. What is item analysis? It is considered a process which examines student responses to individual test items or questions in order to assess the quality of those items and of the test as a whole, meaning we want to find out if each item in a certain exam has a good quality or not. It is considered also the act of analyzing the student responses to individual exam questions with the intention of evaluating exam quality. So in general, we are after with the quality of each item that is considered included in a certain examination. What about the item difficulty? Here, we are after with the percentage of students who answered item correctly, the correct responses of the students. It ranges from 0 to 100, meaning for this, the higher the value we obtain from the item difficulty, the easier is the question. Now, for decision making, whether a certain item is difficult or not, so we have to see to it that the item to be considered should fall within the range of 30% and 70% to be acceptable. If ever it exceeds 70%, that particular item is AC and not acceptable. And if it falls below 30%, the item is considered difficult and unacceptable too. Now, what about the index of discrimination? It is a measure of how well the item can distinguish the knowledgeable students and those who are not. So here, we can compare the correct scores of the fast learners and the slow learners. Using this index, we can judge a certain question or item as follows. So if ever we have computed the index of discrimination and we got the 30 hundredths and above, meaning that certain item should be retained. But if it falls in 20 hundredths or 29 hundredths, you need to revise it. But once it falls in 19 hundredths or below, you need to discard it. So this certain index of reference will be your basis of determining whether a certain item should be retained, should be revised, or discarded. So far, there are three kinds of index of discrimination. First, we have the positive discrimination. Second is the zero discrimination. And the last one is the negative discrimination. Let's find out how one differs from one another. Let us start with the positive discrimination. This is less understandable condition. Why? Because the more knowledgeable students got higher score than that of the non-knowledgeable student, meaning those students who belong to fast learners were able to get the correct answers more than that of the slow learners. Well, if it is a zero discrimination, it is a neutral condition. It's a break-even, wherein there is an equal number of correct responses for knowledgeable students and non-knowledgeable students. And it is considered negative, which is highly undesirable. Why? Because this kind of item is questionable. It can discriminate, but the item is questionable since more non-eligible students were able to get higher scores than that of the eligible students. So, for emphasis, for positive discrimination, more eligible students than eligible students got the correct answer. For zero discrimination, there is an equal number of eligible students and non-eligible students with the correct answer. And lastly, for negative discrimination, this is where the non-eligible students were able to answer the correct answers or the correct items than those of the eligible students. So these are the three kinds of index of discrimination, namely positive discrimination, zero discrimination, and negative discrimination. But how are we going to compute the item analysis? Let's proceed to the procedure. There are 6 steps, and let us discuss it. But let us start first with an example. Here is a sample. Okay. Professor Erica made a 10-item quiz to her only class, which has 13 students. She wants to find out if the quiz she made wasn't too difficult, neither too easy for the students, and if every item was okay. So take note, the given, it is a 10-item quiz with only 13 students. Professor Erica listed the scores of every student. Here is it, from Blaine to Elaine, with the respective scores on the right side. There are 13 students, I repeat. So let us compute the item analysis. The first step, you have to gather the raw data. Consider all the correct and wrong answers in every item of every student. This is it. So with this table, you can see all the correct and wrong answers of the students. But what we are after are the correct answers of the students. Okay? From item number 1 to item number 10. Second, or step 2, let us arrange the students from the highest to the lowest score. So originally, this is the list of students where the scores are not yet arranged. So to arrange it, we have Clyde and Vito got the perfect scores, and Blaine and Maxine got the lowest scores. So, arranging them from highest to lowest. For the item difficulty, we get the item difficulty in each item, every item. So here we have the corresponding item here. Let's follow the formula. In item difficulty, it is equal to T over N, wherein T represents the total number of students who answered correctly in an item. So we are after only with the students who answered correctly, divided by the total number of students in the class. So let us substitute. So we have here 13 students. So the total who got the correct answers, we got 9 in item number 1. We are just only in item number 1. So there are 9 students who got the correct answer over 13, which is the total number of students class. So the result, we have 69 hundredths. To make it percent, we just simply multiply it with 100 or move the decimal point 2 places to the right, which is equivalent to 1969%. Let us take another example for item number 2. Okay. In item number 2, we have 6 students got the correct answer. The same, the N is the total number of students, and with the answer, we got 46 hundredths or 46%. So let us decide here. And you have to follow the same procedure with item number 3 up to item number 10. So let us see. So with here, we have the item number 1 with 69%, item number 2 is 46, and the rest follow with the same formula. And with the item number 10, we got 46%. And you will notice that all the scores are above 30%. So for decision making, all the green color here will be acceptable item, and if it will become red, it is considered not acceptable. So let us look. 69, 46, 38, and the rest are all green. So meaning all the items got higher than 30%, and it is within the range of 30 to 70%, which means that all the items are considered acceptable. They are not neither too easy, neither too difficult. Okay? What about the index of discrimination? The first thing we have to do in computing the index of discrimination is we have to identify the top 27% of the students who got the highest scores, and at the same time the top 27% who got the lowest scores. In other references, we can also use 25%, but in our case now we will be using 27%. It will depend on the teacher or on the formula that we are about to use if what percentage are we going to practice or to adopt. So let us see. Our number of students here is 13. So we have to get the 27% of 13. We have to change 27% to decimal. It will become 0.27. So that means our answer is 3.51. But the score is always a whole number, so it should be rounded off and it will become 4. So we need 4 from the highest scorers, and we also need 4 from the lowest scorers. To show it, we have to count the total of their answers for every item, and the total of the high scorers and the total of low scorers scores. So here is it. So arrange it in chronological order. Let us try to look the 4 high scorers and the 4 low scorers. So we have Clyden, Vito, Dinley, and Nevada. They belong to the high scorers. And for Ashana, Ira, Blaine, and Max Payne, they belong to low scorers. Okay, so let's focus on the respective answers. For high scorers, all of them got the correct answer, so it's a 4. For the low scorers, we have 2 who got the correct answer. For the item number 2, same thing, 4 for the high scorers, and then we have nothing for the low scorers. You have to repeat the procedure from item number 3 up to item number 10. We just count the number of correct answers. Okay, then let's find now how to get the index of discrimination from each item. So this is it. From this table, let us compute the index of discrimination. Our formula here is index of discrimination is equal to the higher number of students who got the correct answer from high scorers minus the number of students who got the correct answers from the low scorers, where n is the number of students in each group. Remember, there are 8 students, 4 belonging to high scorers and 4 belonging to the low scorers. But what we are after here is the number of students in each group. Okay, so we try to look at the different scores of the high scorers and low scorers. So let us apply the formula. So for number 1 item, we have 4 minus 2 divided by 4. And the answer is 0.5. That is the answer. Okay, so you just simply subtract the score of high scorer with that of the low scorer and then divide it by the number of students in each group. So item number 2. That will be 4 again minus 0 divided by 4. So our answer is 1. Okay, that's it. You have to repeat the formula. You just substitute it up to number 10 item. And here are the answers. We have 0.75 for number 3, 0.75 for number 4, and then 1 for number 5, 0.25 for number 6, and 1 for number 7 up to number 10. Okay, now let us see the interpretation. Now take note about the index of reference, that if it falls in the range of 30 hundredths above, you have to retain the item. But once it falls in the range between 20 hundredths and 29 hundredths, you need to revise the item. And lastly, if it falls in 19 hundredths below, you need to discard the item. So let us look at the different index of discrimination. So the first one is 0.5. That means you have to retain. Same thing with 1. You need to retain. So let us try to look the others. With 0.75, retain, except for, what number is that? 2, 4, 6, number 6 item, which is 0.25, and that is below 0.30. No? It falls between 20 and 29, so you need to revise that particular item. So what you have to do is just to adapt the formula, substitute it, and just be careful and look at the index of reference for your interpretation and decision for what you are going to do with the item, whether you have to retain it, to revise, or discard it. Okay, I hope you learned something from this discussion. This is the first part of our lesson about the item analysis. This is very important for us to find out the effectiveness, the discriminating power, and even the validity of each item in the corresponding or respective exams that we are doing. So we need to be careful whether that item will be included or will be retained, will be revised, or discarded. And we should also consider its item difficulty, because in this case, it is very, very important to make the exam more challenging and not boring. So we need to keep that item in the range of 30% and 70%, not to be neither too easy, neither too difficult. So God bless you for having this lesson today. Hope you learned something. Stay safe and God bless you.